Let's take a look and see how these are going. Both of these are kind of tough problems. To help out, sometimes it helps to pull the base out and draw it separately. So for number one here, our base is a trapezoid. The top here is 6 inches. This height is 8 inches. And the lower base is split into two pieces. We have 12 inches there and 15 inches here. So first step, of course, in finding volume or surface area is finding the area of the base. Well, looking at, at this base here, it's a trapezoid with a base of 6 on top, 27 on bottom. That's the 12 plus 15. So we average those together, so add them up, divide them by 2, and then times that height of 8 inches. I believe that comes out to 132 square inches. Double check it. It is 132 square inches. That's the area of our base. So the volume is in the area of that base, 132 square inches, times that height of 20 inches. Which is 2,640 cubic inches per volume. For our surface area. We already have the area of our base, 132 square inches. And it does appear twice. There is one at the other end. We need, for the lateral area, we need to know the perimeter of the base. So we have the 6 here. If I cut this down here, that actually would split this 12 into 6 inches and 6 inches. Now we can find these missing sloped surfaces. This is 6, 8, and then whatever that surface is. 6 squared plus 8 squared equals, I'll just call that x for now, x squared. Gives us that x. I'm going to trust that you guys can do this equation now at this point. That'll give us that x is 10 inches. On this side, we've got 8 and 15 for legs. That's 8 squared plus 15 squared equals, I'm going to call that side y. The y squared, if you solve that, we get that y is 17 inches. Is there anybody that's struggling with the a squared plus b squared equals c squared, wants me to go over how I got the 10 inches and the 17 inches? So for our perimeter, we've got 6 inches on top, 10 inches over here. I already said the total across the bottom is 27 inches, and then 17 inches there. Giving us a total 34, 44, 50, 60 inches of perimeter. So our lateral area is the perimeter of the base, 60 inches, times that height at 20 inches again between bases. Give us 1,200 square inches for lateral area. We add those numbers together, to get a total surface area of 1,464 inches squared. Any questions on that one? How many of you had both of those answers correct? Good deal. Number 2, again, it might be helpful to redraw our base. Oh, it should be the same on both sides. Let me try that one more time over here. That's a little bit closer. So our base here is a rectangle that's 20 millimeters in length with half circles cut out of the sides. To find the width of that rectangle, we know we're given that it's 12 millimeters from arc to arc, so from here to here, which means the difference between 20 and 12 is 8, and that has to be split evenly, 4 millimeters on either side. So those circles each have a radius of 4 millimeters, which makes this diameter 8 millimeters. So when finding volume, to find the area of our base, we're going to start off 12 millimeters by 8 millimeters, giving us 96 millimeters squared. From that, we're going to have to subtract that triangle, or that, sorry, it's that triangle. We're going to have to subtract that circle. We're going to take the 2 half circles and put them together to make one full circle, which would be pi times radius squared, pi times 4 squared, which would be 50.24 millimeters squared. Once we subtract there, we get 45.76 millimeters squared, the area of our base. So for volume, it's the area of that base, 45.76 millimeters squared times our height, which is the 30 millimeters. That's the distance between bases. Giving us 1,372.8 millimeters cubed is volume. For surface area. We have the area of our base, 45.76 millimeters squared, and we have 2 of those. So all we need to worry about is our lateral area. For our lateral area, we need the perimeter of the base. Well, for the perimeter of our base here, we have 20 and 20 for those sides, and then we have the circumference of that circle once we put it back together. 20 millimeters plus 20 millimeters plus that circle will be pi times 8, which is 25.12 millimeters, giving us 65.12 millimeters as the perimeter of our base. So our lateral area is the perimeter of the base, 65.12 millimeters, times our height of 30 millimeters, giving us 1,953.6 millimeters squared is the lateral area. So we'll add these up. I mean, 2,045.12 millimeters squared is our total surface area. What do you think? Not terrible? Okay. We'll see if I can draw this here. So we have a box here with a pyramid on each end. We're going to go 12 millimeters of width here. .25 millimeters on the length of our box. And we are assuming that this is also 12 millimeters here. I want you to find for me volume and surface area. Remember, volume can be strictly added, but surface area, you got to worry about what surfaces are covered up and not included. I'll give you a few minutes and then we'll go over those. Let's see how this is going for you. So for volume, we have three shapes here. We have the box, and we have the two pyramids. The two pyramids are identical. So for the box, we can pick a base. I'm going to pick this end to be the base, just because that is the same as the base of the pyramid. So for the box, the area of my base is 12 millimeters by 12 millimeters, or 144 millimeters squared. So that volume, 144 millimeters squared times the 25 millimeters of height. That's the distance between bases. I believe that's 3,600 millimeters cubed. Let me double check that. It is. So that's the volume of the box portion. For the pyramids, for pieces 2 and 3, I'll just do piece 2 for now. We have the area of the base is the 144. The height, well, it's going to be 10 millimeters on each side here. So the height is times 10. And it is divided by 3 because it's a pyramid. But of course, then it'll be times 2 here, because there's 2 of them. There's 1 on each end. So 144 times 10 divided by 3, and then of course times 2, because there's 2 of them, is 960 millimeters cubed. That's for both pyramids. We add that up. Got an extra 0 there. 4,560 millimeters cubed is the total volume of that. For surface area, well, for piece 1, for the box, all we have is the lateral area. Both bases are covered. So we find the perimeter of the base, which is just 12 plus 12 plus 12, or 12 millimeters times 4, is 48 millimeters. So that lateral area is at 48 millimeters times that 25 millimeters of height, which is going to give us 1,200 millimeters squared. That's all of the area that's contributed from the box portion. Like I said, both bases are covered. For the pyramids, all we have is lateral area as well. The bases are covered there also. Our perimeter of the base is still 48 millimeters. It's the same base as we had on the box portion. We need to know the slant. We're going up here, finding that slant. Well, this is 6 millimeters here, half of my 12. This here is my 10 millimeters, this distance. So I'm finding that. So I have six millimeters, 10 millimeters. This is what I'm trying to find for my slant. So 6 squared plus 10 squared equals S squared. So I'm just going to do 6 squared plus 10 squared should give us 136. We square root, that's 11.66 millimeters. Is that slant height? So our lateral area there is that perimeter of the base, the 48 millimeters, times the slant height, 11.66 millimeters, divided by 2 because these are pyramids, so they come up into triangles. Then, of course, times 2 because there's 2 of them. I'm not going to divide by 2 and multiply by 2 because it's going to just cancel out. So for the 2 pyramids, we've got a total lateral surface area of 559.68. Millimeters squared, which adds up to 1759.68 millimeters squared total surface area. What if I wanted to convert that into centimeters squared? What do I do? Well, to go from millimeters to centimeters on our chart is one spot to the left. But since this is millimeters squared and centimeters squared, how many spots does my decimal point have to move? 2, very good. Every spot on the chart becomes 2 decimal places because it's squared. So I have to go 1, 2, that's 17.5968 centimeters squared. Our volume that we had of 4,560 millimeters cubed. If I wanted to convert that into centimeters cubed, still one spot on the chart from millimeters to centimeters, but since it's cubed, the decimal point has to move how many spots?
3.
3, good. Every spot on the chart becomes 3 decimal places when it's cubed. So 1, 2, 3, that's 4.56 cubic centimeters. So now an exercise that we worked on a little bit quite a while ago, I want to go over it again here, is converting to an inch to the nearest fraction of an inch. So let's say I have something like 7.439 feet. And I want it to the nearest 32nd of an inch. I want this in feet, inches, and then whatever the specified fraction of an inch is. Well, I will start out with my whole feet. This is starting in feet, so all I have to do is take the feet off. I have 7 whole feet. Then I take the decimal portion here, 0.439 feet, and I'm going to convert it into inches. I'll do that by simply multiplying 1 foot is 12 inches with 0.439 times 12 gives us 5.268 inches. So that means I've got 5 inches. I'm going to take the 5 off of that. I'm going to continue working with the 0.268 inches. On the calculator, that just means I'm just going to subtract the 5. The parts in front of the decimal point, I just subtract off. I'm left with the 0.268. Now I have to look to see what fraction I want. I want it to the 32nd. So I want to change my 1 into a 32, so I'm going to multiply it by 32. I multiply the numerator, the 0.268, by 32 as well. Give me 8.576. Well, this 8.576 is between 8 and 9. It's closer to 9, so that's 9/32. This is 7 feet 5 and 9/32 of an inch. So we started with feet and converted to the nearest 32nd of an inch. Feet, inches, and 32nd. Well, what if we started with inches? What if we started with 79.641 inches, and we want that to the nearest 16th of an inch? Well, our first step now has to be to find the whole number of feet. So I'm going to start out with my 79.641 inches, 12 inches in a foot, so I'm going to divide by the 12. Gives us 6.63675 feet. Now, of course, off of that, all I want is the 6, the whole feet. So on the calculator, all I'm going to do is whatever number's in front of the decimal, I'm going to subtract that. So I just subtract the 6, leaves me with the decimal. Now I have to turn that decimal, 0.63675 in this case, back into inches. So I'm going to multiply by 12 again. That gives me 7.641 inches. Again, from that, I want the 7 for my whole number of inches. Take my 0.641 inches, my decimal portion of the inches. So off of this, I'm just going to subtract the whole number again. I'll subtract the 7. And I'm going to multiply. I want my denominator to be 16 this time, so it's going to be 16 that I multiply by. So 1 times 16 does give me 16 for denominator. My 0.641 times 16 gives me 10.256 is my numerator. Well, that's between 10 and 11. It is closer to 10. That's 10/16, which reduces to 5/8. So that is 6 foot 7 and 5/8 inches. So the process, you can see, is slightly different depending on whether we're starting with feet or starting with inches. Realistically, if we're starting with inches, we just divide by 12 and then we go from there just like we started with feet. It's just that little extra step to begin with. That packet out there from last week, the big area and volumes packet, one of the front pages, the Clayton High School packet, one of the front pages, page 79, has about a dozen problems where we're asked to convert to inches and a desired number of desired fraction of an inch. Also, there is a new quiz out there. I believe it's quiz 10-11 in Blackboard for you. This one will take some time. So it says on there that it's due tomorrow, but there will be in class tomorrow. I will take time to answer questions if we need to. We are actually a couple of days ahead of schedule right now, so I can slow down for just a couple of days here, take our time with that quiz, and make sure we've got this area and surface area and volume stuff down before we move on too fast. Any questions? Okay, we got about 6 minutes left. So I'll let you guys have that last 6 minutes to get started on your homework or that packet or quiz, whichever. I will be here if you have any questions. Otherwise,